Hey guys, welcome to chapter 3. Before we get rolling here in chapter 3, let's do the warm up here. Okay, 3x plus 2y equals 6. We're going to graph that. Instead of solving for y, what I'm going to do is I'm going to do the intercept form. So what that means is that when I solve for my x-intercept, that means y is equal to 0. If I put 0 in for y, that means I have 3x equals 6, so x is 2. So there's my first point to 0. There you go. Next intercept I'm going to find is the y-intercept, which now means x is 0. So that would be 2y equals 6, so y is 3. So that means my point is 0, 3, and I'll have my line there. Okay? Basically that guy there. So there's your first graph. Okay? Second graph, we'll do in red here. This one I'll solve for y actually. This will be x minus 4 equals 2y. This is x 1/2 minus 2 equals y. So negative 2 would be my y-intercept, and then I'm going to go over 2 up 1. So every time I do that, I just went up 2 there, it's going to yell at me on the screen. So there's your warm-up. If I connect those, there's my graph. Okay, so two different techniques there for 1 and 2. Otherwise, I'm going to skip right through here and get started with your notes. So. Okay, looking at your section, we're solving linear systems by graphing. So you're going to have one graph on top of another graph. That will become a linear system, because you have two linear equations where they intersect or where they don't intersect would be your solution. Or maybe they intersect at multiple points. So you can see here two or more linear equations in the same variable form a system of linear equations. So equation 1's on top, equation 2's on bottom. There's multiple ways of solving this. You have substitution, linear combinations, and now we're just going to look at the graphing. Okay, it's their points of intersection. This is really what the key is here. Okay, this is called the point of intersection of the graph. That's your solution where the two intersect. That's your solution. So, to practice these, okay, we're just going to check using algebra whether this is a solution or not. So negative 2, 1, this here has to work with the top and the bottom. If you plug it into the top to show all my work, this is what it would look like. So this is negative 12 minus 3, negative 15, absolutely. Top one to go. This is a good one. This one works. Let's check the bottom. 2 times negative 2 plus 1 equals negative 3. Absolutely. Negative 4 plus 1 is negative 3. So, yes, this is a solution. Follow your directions. We'll be big on that this year. If I don't ask you to do something, well, then I can't very well hold you accountable. So, make sure you follow directions and test and put it. So let's do the same thing with 6. So, negative 2 times 6 plus 1 equals 11. So this is negative 12 plus 1 equals 11. Negative 11 does not equal 11. This is a no-go. Don't even bother checking the second one. You'd be wasting your time. So this is no. No dice. That will not be a solution to the system. It may be a solution to one of your equations, but it has to be a solution for both. For example, if you plug it in here, you'll see that will work. The answer is no, because it didn't work on the top. Okay, so write each equation in a form that's easy to graph. That can be a lot of the stuff. That could be slope-intercept form. It could be just solving for intercepts in standard form. Graph both equations in the same coordinate plane, estimate the coordinates of the point of the intersection, then you're going to go ahead and check it by substituting that point into both the originals. And it's always good to use the original linear system here, as I get the right thing. Don't plug them into something you solved, because if you made your mistake in what you solved, you won't know if you did it incorrect or not. So always go back to the original. All right, so let's go ahead and do 3 and 4 here. I'll fly through 3. This would be y equals negative x plus 4. So, up 4, 1, 2, 3, 4, slope of negative 1. So that means as I go to the right by 1, I'm going down by 1. Okay, so here's my graph in blue for this guy. I'll do the bottom one in red. This would be y equals negative 2x plus 5. So now I'm at 5, I'm going to go down to 2. And that's nice because the one point I just drew was right on top of the other one. So that makes me not have to guess what my solution is. So it looks like 1 up 3. So if I plug 1 in here, 1 plus 3, is that equal to 4? Sure. If I put 1 in there, that's 2 plus 3 equal 5. Sure. So, yes, we got a solution at 1, 3. Okay? Let's go to the next one. I'll start a maroon here. So the top equation, what I'm going to do is I'm going to add 2y over and subtract 2. So this is 3x minus 2 equals 2y. That will give me the equation then of y equals 3 over 2x minus 1. So negative 1 over 2 up 3. Over 2 up 3. Okay, over 2 up 3. Back 2 down 3. I'm going backwards. There's my graph for the top equation. Let's go ahead and do the bottom one. So this will be 2y equals negative x plus 6. I'm going to divide by 2. This is negative 1/2 x plus 3. So let's start at 3 here. I'm going to go over 2 down 1. And there's my intersection. Okay, so that would be 2, 2. So let's plug this ahead in the top one. 2, 2. So this would be 6 minus 4. Sure. Let's plug it in the bottom one. So this would be 2 plus 4. Sure. So this is a good solution. Yeah. 2, 2. Okay. So there's 3 and 4 completed for you. Feel free to pause the video at any point. Move ahead. Let's jump through 5 and 6. Now that we know what we're doing here, I'm going to add y, add 2, so y will equal x plus 6. So 2, slope of 1. There's my line. Use red for the bottom one. This is y equals negative x minus 4. So 1, 2, 3, 4. Slope of negative 1. There's my solution. So that would be 1, 2, 3, negative 3, down 1. So that's the point I want to check. So we're looking at negative 3 minus negative 1. So this is plus. Negative 3 plus 1 is negative 2. Sure, that works. Plugging it into the bottom one. Okay, I have negative 3 plus negative 1. Does that equal negative 4? Sure it does. So yes, we have negative 3, negative 1 as our point of intersection. That's your solution. All right, top equation, I'm going to add y, subtract 1. So if I add y over, and then I'm going to subtract 1 over, so this is going to be y equals x minus 1. Bottom one here, I'm going to have 5x equals 4y, which then means y is going to equal 5 over 4 times x. So let's start with the top one in orange, negative 1, slope of 1. Okay, going with the purple one, 0, so I'm going to go up, y's over 1, so 1, 2, 3, 4, 5, 1, 2, 3, 4. Let's go backwards, 1, okay, down 5, 1, 2, 3, 4, 5, back 4, 1, 2, 3, 4. There she is. So this point down here would be, let's see, 1, 2, 3, 4, negative 4, 1, 2, 3, 4, 5, down 5. So the point we want to check is negative 4, negative 5. So let's plug that in up here. Negative 4 plus 5, does that equal 1? Yes. Let's check the bottom one. 5 times negative 4 is negative 20. 5 times negative 4 is positive 20. Yeah, 20 minus 20 is 0. That works. So yeah, that one checks out. Okay, so we're going to keep plugging away here. Same thing we're doing here in 7, 8, 9, and 10. So we're going to have basically, I'm going to add 2y over, so I'll have 3x minus 6 equals 2y. Divide everything by 2, so this is 3 over 2x minus 3 equals y. So down 3, over 2 up 3, over 2 up 3, over 2 up 3, and so on. Backwards, do the same thing, just going down. Okay, so there's my top equation. Bottom equation, so I'm going to add 4y over, so this would be 6x minus 12 equals 4y. If I divide by 4, I'm going to have 3 over 2x minus 3. 6 over 4 is 3 over 2, guys. Reduce it. That's why I have it like that. What you're going to see is this is the exact same line on top of each other. So all real numbers would be your solution, or there's an infinite number of solutions. Okay, so whatever you put in for x, you can get a y value for every solution because they're the same thing. So that's an infinite number of solutions. Okay, all real numbers will yield a correct answer. Now, looking at this one here, I can see that basically they're the same thing, just equal to different things. I'm guessing this is no solution, but to show you here, I'll go through the steps. So this is 3 over 2x minus 3 equals y. Here comes the bottom one. So this will be 3x minus 2 equals 2y, divided by 2. So this is 3 over 2x minus 1 equals y. So I'm going to graph that one y over 2 up 3, over 2 up 3, over 2 up 3. Draw that line. Here comes my blue one, down 3, over 2 up 3, over 2 up 3, over 2 up 3, and so on. So you can see these lines are parallel, which means they never intersect. Thus, therefore giving you no solutions. Okay, so there's 7 and 8. Oops. Let's get 9 and 10 up. Okay. So starting with 9, I'm going to add 6x over. So this is 2y equals 6x plus 8. Y is going to equal 3x plus 4. So up 4, 1, 2, 3, 4. Slope of 3. That's going to get knocked out quite quickly. Okay, so there's my first line. The next one would be a 4, slope of 3. Ha! Same equations. So that means they are an infinite number of solutions for this guy, because they're right on top of each other. Let's start over here. This is y equals negative 3/4 x plus 5. So 1, 2, 3, 4, 5. Over 4, down 3. Over 4, down 3. Back 4, up 3. There's my line. That was a good one. Here we go. 4y equals negative 3x plus 2. And we'll put that over 4. So y equals negative 3/4 x plus a half. So if you started a half, I'm going to go over 1, 2, 3, 4, down 3, 1, 2, 4. 1, 2, 3, 4, 1, 2, 3. Okay, so these share the same slope, negative 3/4, they never intersect, so no solution. Notice this has a slope of 3/4, he has a slope of negative 3/4, both are negative 3/4, thus no solution. So you have to write a system down here. You can check them, one solution, just make sure you're like...
Pardon the interruption. Any BCTC student who did not have their picture taken on Wednesday should report to E217, E218 at this time.
So the key here is when you do one solution, make sure your slopes are different. When you have no solution, make sure the slopes are the same but your intercepts are different. And if you have infinite, just make sure they're the same equation. Okay, so this would be 2x plus 2 again. That's fine. All right, so that's section 1. See you guys later. Ciao.